Thank you, Jeff. Good morning, good afternoon, everyone, wherever you are. So indeed, I am Bryce. I'm a research associate at Virginia Tech in Suffolk. I'm going to talk about the use of multispectral drone camera to differentiate drought tolerant reels of peanuts grown under Rainout shelters. Is that working? No, it's not working for some reason. Okay. So we all know that peanuts are economically important with a yearly value above $1 billion per year for those last 10 years. However, peanuts are very sensitive to drought event, which can affect yield and quality. You can see this chart representing the rainfall in millimeters for each week of the growing season of peanuts. And you can see that in July, August, we are not reaching the 50, 75 millimeters per week required for the pod feeding stage. And that can result in loss of $50 million per year in Virginia and Carolina regions. So what can we do? We need to push the producers and growers to adopt drought-tolerant cultivars. Fortunately for us, there is an important genetic variability which exists in peanuts, giving us a high potential to find some, to create some drought-tolerant cultivars using breeding technologies. But doing breedings require a lot of phenotyping field testing, a lot of data to collect. It's taking a lot of time. It can be very subjective for the ratings, such as wilting, for example. So we need to try to find some alternative, and the emergence and fast development of the remote sensing technology, such as drones, could be a reliable, accurate, and high throughput alternative to those phenotypic field testing. So my objectives were to phenotype a peanut recombinant inbred line population to assess their pod yield under irrigation and under Rainout exclusion shelters, and to try to identify the highest yielder, but also the best drought tolerant reels. As material and method is going to be in two parts. Just as a reminder of what I presented last year in my poster, we screened the recombinant inbred light population in 2019 under rainfed condition only. That was done in Suffolk, Virginia, and Lewiston in North Carolina. My student Navin Kumar, who presented yesterday some ground measurement, took those measurements here you have on the screen. And I took some imagery using this Falcon 8, which was equipped with different variety of cameras. We use that this reed population, which come from the cross of these two parents, one high-yielding line and one drought-tolerant Spanish line, which resulted in a population of 340 reels. I presented that graph last year, which presents the pod yield of all those reels under rainfed condition. We have a very important variability for this yield, with a lot of reels presenting a yield above the check, which is Bailey. However, if you want to go more in depth in analyzing their response to drought stress, you cannot do some in-depth phenotyping for 340 reels. That's going to be very problematic. So our student did a selection that he presented yesterday in his talk of 52 reels, which can be now screened more in depth for drought stress. So we reach the second part of the material and method, where we try to compare the real subset under irrigated versus drought condition. This is done in Suffolk in Virginia. Our student is still taking those ground measurements. And I'm flying another drone, but equipped with a 6-band camera, the MicaSense Altum. This camera allow me to take an important variety of traits, plant height estimation. Some speakers talk about that this morning, canopy temperature, NDVI, NDRE, which is very close to NDVI, but has a chance to not saturate like NDVI for peanuts, as well as some RGB-based indices using the BreedPix plugin developed by the CMIT. And those indices were presented on Monday by some of the students. We use a rain shelter for those 52 reels. We use 2 check Bailey as well as a GPNCWS 17. Here is a timeline of our experiment. One field was planted and was irrigated treatment. They were irrigated throughout the full growing season. The second field, the rain shelter field, was irrigated until DAP 53, when the rain shelters were put in place for 55 days. At DAP 106, the shelters were pushed away, plants were irrigated again, and we could see the difference resulting from the drought stress as well as the recovery of the plants. This is a 2-year experiment. I'm showing you some highlights of what I'm analyzing for the 2020 data, and we are currently having the planting field right now for 2021. Here is a view from my drone. That's an orthomosaic created from using the drone. You have the irrigated fields on the right. You have the rain shelter fields on your left, while the shelters were in place at that time. First, the pod yields. Here you have only the irrigated entries, the 52 entries under irrigated treatment. We can see that we have an important variability of pod yield. Here the red line is at Bailey. And what is interesting is several entries are presenting a yield higher, a pod yield higher than our cultivar. Now the orange bar represent the pod yield under drought stress treatment. First of all, we still have that big variability between the different entries that we are considering. What is of interest, it's also all the pod yield is below under drought condition as compared to the irrigated treatment. Now, if we look a little bit closer here, that black square for the two checks, Bailey and WS17, they present a different type of adaptive response to drought stress. We have Bailey, which is not a drought-tolerant cultivar, which is losing 70% of the pod yield under drought condition, while WS17, which is a drought-tolerant germplasm, is losing roughly 20–25% only. And we can see that across all the different lines. Here I'm presenting a graph showing the percentage of loss of pod yield in the rain shelter entries as compared to their irrigated counterpart. I'm gonna put this red line for the WS17 germplasm, which remind you is drought tolerant. And we are lucky to have some entries having roughly a stability under drought stress and not losing too much of their pod yield as compared to their irrigated counterpart. If you focus on this green circle here, we have even two entries almost having no change of their pod yield under rain shelter versus irrigated. But it's not only a question of having a stability and not losing yield under drought stress, it's also what's happening in general. What is the pod yield in general? So this is what this graph is showing. It is showing the yield as a percentage of Bailey under irrigated conditions, okay? So if we look at those two here in the green circle I talked about in the previous slide, the first one on the left is indeed was having a huge stability and was not having a yield loss. It was even have a small increase of the pod yield. However, you can see that its yield is very low compared to Bailey under irrigated conditions. So this entry is not interesting to move forward with. The one on its right, the entry 71, was about stable, but is also having a yield roughly close to the one of Bailey. So this line is interesting to keep, however. So that is the same story for all the one with a black star here on your screen. They have roughly a pod yield very close to the one of Bailey under irrigation, even slightly higher for some of those. And under drought stress treatment, they are not losing too much of their pod yield. So we would like to select those ones to move forward. I try another technique that you have here on the screen, the Ward method of clustering, to try to see if those entries were close to each other. And you can see in the tree that all the ones with a star are clustered in the same area in that tree. Now, what's going on when we don't use a pod yield, but we use the remote sensing data? I selected data from the DAP 106, which was the day the shelters were removed. That was the first flight once the shelters were removed from the field. So the plants were just, out of their drought stress. I created this PCA, which explained 83% of the trait variability just using component 1 and 2, as you can see on your screen. We have a very strong clustering of the plant under drought stress versus the plant under irrigation treatment, as you see with those two red and blue circles on your left. We saw previously that the plant under irrigation were having a higher pod yield, which would mean that if we focus on this one, we should focus also on the right side of the PCA, where we have a high NDRE value, high height value, etc., etc. Then my next question was, we see those results at DAP 106 once we remove the shelter. How the things are changing when the plants are recovering from the drought stress in the following days and weeks. So we keep this one in the corner. And I checked at DAP 113, which was 1 week roughly after we removed the shelters. We still have this very strong clustering of plant under drought stress, which were under drought stress versus the plant which are still under irrigation. And at DAP 129, which was the last flight before the plants were dug in October, oh, sorry, my phone is ringing. We still have this big clustering. The plants start to merge a little bit in this area. So we still we start to have some recovery from the plant, but we still have some very important clustering. Now, this graph is only one example using one of the traits, GA, which is a green area. So the green area, if you remember what was presented earlier in this conference, is the percentage of pixels which are green, meaning with a U angle between 60% and 60 degrees and 120 degrees. So you can see that on the right, when you remove everything which is not within this range, you have only the plant remaining in this image. And you have in this graph those GA percentage in the plant under irrigation treatment, the full line, and the dashed line are the one under rain shelter. You can see the void here. It's obviously I cannot fly under the shelter, but you can see that the GA values is far lower for the plant which were under rain shelter, under drought stress, as compared to their irrigated counterpart. However, you can see that by the end of the growing season, this percentage is increasing. So the plants start to recover. And if we were to fly again several times before digging the plant, most likely the plant would have reached their maximum at 100% of canopy cover. Now, to the last result, what I'm trying to do is we still using those PCA, but can we actually select within the rain shelter treatment? Can we select some entries versus others, which would be high yielding and drought tolerant? So I use those PCA data. We still have a very high explanation using component 1 and 2, above 80%. I managed to cluster them based on the data. And if you recall what we showed previously, we would like to be on the right side of the PCA and select the ones here in my green circle, which would have a high GA value, a high plant height, a high NDRE value, etc. The current data that I got this week shows that we have only 50% of the plants that I pre-selected and that I showed you in my previous in one of the previous slides are present in this green circle. So
about a minute to go, Bryce.
Thank you, Jeff. So we start to have some very nice data, but it is not yet optimal to be used for selection. Last slide for conclusion. So we got a potential among the risks to select some high yielders, which are stable and drought tolerant. The UAV indices can be used to differentiate the plants under irrigation versus plants under rain shelters. The UAV indices could eventually help in selecting the reels for to find some high yielders and drought tolerant, but we still need a little bit more work to refine this selection, to improve this selection. I want to thank my team leader, Dr. Balota, my team members, Navin Kumar, the student who presented last year. It is his PhD project, as well as all my coworkers and the funding agencies Unifacare. Thank you very much.
Excellent. Thank you, Bryce. I think we have time maybe for one quick question if there's one that's out there. Otherwise, we're going to have to move on to the next presentation. Not seeing any, so I think we're going. Oh, we got one from Mustafa Yilmaz. How do you choose the drought-resistant lines?
Let me go back to this graph. So I chose them this way. I firstly pre-selected the one, you see my screen, right? You still see the screen.
Yep.
I pre-selected the one which were having the smallest loss of yield under rain shelter as compared to their irrigated counterpart. For this one, for example, you have a loss of 20% as compared to the same reel under irrigated treatment. And then on the next stage, here, I just check their yield as compared to Bailey under irrigated treatment. So I wanted a reel which was not losing too much under drought stress, but also a reel which was having a high yield as compared to Bailey. So similar to Bailey or above Bailey.
Great, thank you.